So before starting my presentation, I would like first to take this opportunity to thank you for accepting my paper. So my name is Hamim Mohammed. I'm a second year PhD student in Big Data and Artificial Intelligence. So the title of my publication that I'm going to present is Decision Tree, Model-Based Gene Selection and Classification for Breast Cancer Risk Prediction. So this is the content of our presentation. We start first with an introduction to have an idea about context and aims of our research. We next move to talk about our proposed approach used to deal with the problem of high dimensionality of data. And then we talk about our framework used to improve the breast cancer risk prediction. The fourth section is devoted to discussing experimental results. And we finish our presentation with a conclusion. So, affecting around 2 million women each year, according to the World Health Organization, the breast cancer is ranked as the second cause of cancer-related death in women after lung cancer. So, the diagnosis of breast cancer at an early stage may allow for a good chance of treatment success, which can put in evidence a strong need to develop a prediction system that can detect breast cancer at an early stage. So, using gene expression data, the objective of our research is to develop an integrated breast cancer risk prediction system that combines a new feature selection approach with pattern recognition algorithms. So, with the development of microarray technology, gene expression analysis has become an effective tool in biomedical researches, since it enables to evaluate the expression levels of thousands of genes simultaneously, which has attracted considerable researchers' interest in prediction and diagnosis of different kinds of cancers, especially breast cancer. However, using microarray technology to predict breast cancer isn't without any challenge, since the existence of a huge number of genes against a small number of specimens may negatively influence the credibility of any prediction system. To deal with competitions involving a large number of features, many high-dimensional classification tasks have been developed for breast cancer risk prediction problem, like for example statistical models, decision and regression tree, etc. The term features here is used in general context, but when it comes to using gene expression data, the term features can be replaced by the term genes. So before looking for overcoming this problem of high dimensionality, we need first to understand its meaning, the meaning of high dimensionality. So if we represent our dataset in form of NP matrix, X consisting of n features, with dimensionality p, we can say we are faced by a high dimensional research space problem when the number of observations p greatly exceeds the number of features or genes in the context of gene expression data. So in order to overcome this problem of high dimensionality of our gene expression data, we proposed a new approach-based gene selection that combines two feature selection methods in two-step gene selection system. The first step consists in extracting the most informative genes by using Fisher score-based filter method, and then we use the inner feature selection ability of C5 decision tree classifier to determine a small subset of genes that allows the highest breast cancer prediction performance accuracy. So before talking about our proposed feature selection approach, we need first to understand what does feature selection mean. So as we said before, technically, performing classification using gene selection data might appear to be time-consuming and resources. So feature selection is a powerful technique that allows us to significantly reduce our research space by selecting only relevant and informative features and removing redundant or noisy features, which might improve computational speed and prediction accuracy. So as we said previously, our gene selection approach consists of two-step system. The first step consists in using Fisher score-based filter method, and then we use the feature selection ability of C5 algorithm. So here the question that occurs to us is, why this choice to use a filter method as a first step in our gene selection approach? So the answer here is so simple. Since filter-based feature selection methods are faster than any other feature selection methods, which means that by using filter method, we are going to reduce the dimensionality of our research space in a very effective and fast way. So to measure the feature's relevance using filter methods, some statistical techniques are applied for each feature, such as Pearson's correlation coefficient, Spearman's rank correlation, and many other techniques. As we are here faced to a binary classification problem, we used the Fisher score method. So the principle of this technique is so simple. So we focus on a subset of features for which the distances of the data point with different classes should be as large as possible. And the distances between the same classes should be as small as possible. So using this method, our gene subset is determined in 2 steps. The first step consists in computing the score of each gene by using this equation. And then all genes are ranked by their importance, and the top 10% ranked genes with high scores are selected as the most informative. So as we said previously, the second step of our proposed gene selection approach consists in using the inner feature selection ability of C5 decision tree algorithm. So before talking about this inner ability, let's take a look to this classifier. So based on decision tree, C5 is a new popular classification algorithm developed from C4.5 algorithm. So compared to its ancestor, this algorithm takes its reputation from many advantages, like for example its ability to handle different kinds of data. It can also deal with missing values and outliers. Its high speed and high classification performance, especially with high-dimensional dataset. It can support also boosting and cross-validation process. And the most important characteristic that we are interested in, its ability to get rid of unhelpful features from data. So in the context of gene selection using C5 decision tree, the information gain ratios of each gene is calculated using the formula as follows. So using this formula, the gene with the highest information gain is voted to be the root node of the tree. Remaining genes are divided into branches by computing and assigning the highest information gain to each branch node. The process continues until a predefined criterion is accomplished. As the tree was pruned, the optimal genes subset is determined. So this is our proposed framework used to improve breast cancer risk prediction. So as we can notice, before applying any process of gene selection or classification, we start first with splitting our data using stratified k-fold cross-validation evaluation technique. The stratification here is used to have the same proportions of instances in terms of classes in all k-fold. And then we use the z-score function to standardize our data. Then we apply our proposed gene selection approach that combines Fisher score with the inner feature selection ability of C5 classifier. So after selecting the subset of the most informative genes, we classify data using 4 classifiers: artificial neural network algorithm, logistic regression, C5 decision tree, and separate vector machine. The classification results of these classifiers are then used to evaluate the effectiveness of our proposed gene selection approach. So to evaluate the effectiveness of our proposed gene selection approach on breast cancer risk prediction, the well-known metric accuracy was used, which represents the proportion of correct predictions among the total number of cases examined. So the established framework is applied to a publicly available dataset, breast cancer dataset. The dataset contains 24,491 scanned gene expressions within 97 instances, 51 of which are healthy and the rest are diagnosed with cancer. So to show the impact of our dimensionality reduction approach on our breast cancer prediction system, it was necessary to apply our 4 proposed classifiers on our dataset without any feature selection process. And this is the experimental results. As we can notice from this table, using all our research space, the prediction performance in terms of accuracy doesn't exceed 86% for most of constructed classifiers. However, when applying our gene selection approach, a significant increase in terms of performance was achieved, especially for C5 decision tree algorithm and supervector machine algorithm, which has reached to about 93% using only 5 selected genes. As we can notice also from this table, using our proposed gene selection approach, our research space size was reduced 2 times. The first reduction was from p equals 24,481, which is the original number of genes in our research space, to k equals 2,448 by using the Fisher score-based filter method. And the second reduction from k to k prime equals 5 genes using the Fisher selection ability of C5 classifiers. So, as our aim behind this study is to predict with high performance the breast cancer risk, we can vote for the choice of FC5C5 model with 5 genes, since it achieved the best couple performance prediction and the number of involved genes, which is much better compared to what was reported in the state of the art of our publication. So after conducting experiments using the stratified chain fault cross-validation evaluation technique, our proposed approach achieves the highest performance for dimensionality reduction in terms of accuracy and number of involved genes when it's coupled with a decision tree classifier. So, as a future work, our proposed approach can be further improved on different aspects, like considering other bio-inspired algorithms, also including experimentation on new microarray datasets, which may help to test our approach far more. So, thank you very much.